When we open up the plugin, this is what comes up. Looking at a glance, we see two bands with a similar set of controls on both, and these two meters in the center. The meters have a plus-minus 12 dB range, with indicators at 3, 6, and 12, and this red needle to plot the gain. Underneath the meters, we have a safety limiter on the output, which we can turn off and on, and an oversampling control, which can be turned on or off. The oversampled components are fixed at a ×4 rate when this is enabled, which seem to be the best trade-off for aliasing reduction and CPU use. Then we will look at the aliasing in Plugin Doctor later on in the video. Oversampling does introduce a small amount of latency, but with oversampling off, it is latency free. It is important to note the safety limiter is not oversampled, and it is recommended to turn the feature off once you've dialed in the behavior you want. Some controls can get pretty extreme, so that's why it starts with it enabled. As we start to look closer, we notice the input and output trim controls on the upper corners, both with plus-minus 12 dB of gain. Below those is an independent bypass switch for both bands. Then a drop-down list to select the channel operation, with stereo, mid, side, left, and right options. And below that, a gain reduction limit control for each band, which we will come back to shortly. Across the top of either band, we have 4 buttons. The first button selects the filter type for the band, and we can choose either a shelving filter or a peak filter. The next selects the mode for the sidechain detector signal. There is a crossover mode and a peak mode, and we will talk about this more shortly when we look at the signal flow diagram. The next button, comp mode or compression mode, has 3 selections: soft by default, hard, and then a manual mode. When manual mode is selected, we have 2 slider controls that come up below each band, with direct control over the knee and ratio settings. The soft mode uses a wide knee and a 2:1 ratio, while the hard mode uses a more aggressive knee and a 4:1 ratio. The manual mode allows knee settings from 0 dB to 24 dB, and a ratio from 1.5:1 to 10:1. The last button across the top of the bands is Auto RLS, or Auto Release, which we can turn on and off for each band independently. So now we will look at these 8 kind of main controls for each band. First control is for the band's frequency. The low band goes from 15 Hz to 1 kHz, and the high band goes from 400 Hz to 28 kHz. And we will look at the filter shapes in an analyzer later on in the video. The next control is for the filter's quality, or a Q control, how resonant the filter is, and it ranges from a very gentle 0.1 to a very steep 5.0, and defaults to a natural sounding 0.7. Also, if we take the control all the way down, we see this wide setting, and when this is set, it bypasses the filter completely, and the dynamics behavior operates across the entire signal, or wideband, like a traditional compressor. The next set of controls are for attack and release, and these have a fairly broad range, with the attack going from 100 milliseconds down to 20 microseconds. And the release goes from 50 milliseconds to 1.5 seconds, with 10 milliseconds and 200 milliseconds being the default values for the attack and release respectively. The ballistics are modeled on the behavior of a feed-forward VCA type topology. When we turn the auto release on, the release control switches to AR time, which sets the maximum or slowest time the auto release will target. Moving to the bottom row of controls, we have a gain control for the band, which can be used for EQ boosts and cuts, or as a makeup gain for the dynamics behavior. The next control is the threshold for the dynamics behavior, and this operates in a clockwise fashion, with the idea being the more you turn it up, the more compression you will be getting. Now for the mysterious XComp control. And to explain this, we will need to listen to some audio and have a look at these meters. So let's start dialing in this low band to see some gain reduction happening on the meter. Notice we see nothing happening on the high band. When we start to turn the XComp control, notice how we start to see a reflection of the dynamics behavior from the low band into the high band, but inverted. So it acts as an expander that follows the mirror of the gain reduction. When the low band is reducing gain, it is increasing gain on the high band. And this control lets us blend in how much of that expansion crossfeed signal we want. And it uses a similar ratio type convention to express this. At 1:1, the reduction and crossfeed expansion signals are the same gain amount. And the control can get pretty extreme at the maximum 2:1 ratio, where the expansion is twice the gain of the reduction. At 1:2, it is half and decreases as we move all the way to the left, where we turn it off completely. And we can do the same thing with the high band into the low band. We will set that to do some compression also, and then feed the XComp into that band as well. And this is how we set that complex dynamic movement, with the goal being to increase the dynamics of the audio without the overall loudness being affected, like would typically happen with traditional expander or dynamic EQ tools if we were to gain match them to the original signal. So here's what we've got. And then with it back off. The final of the 8 main controls affects the sidechain signal going into the detector, and these will be more easy to understand if we take a brief look at the signal flow inside of QXComp. Remember how there are 2 sidechain detection modes? Well, this is what the crossover mode looks like. The input signal is tapped to the sidechain and then split with a crossover, with the lower portion going to the low band detector and VCA, and the higher portion going to the high band detector and VCA. And the controls let us set a high pass filter for the low band sidechain, and the crossover frequency can be accessed from the control on the high band. And this is what the peak mode looks like. 2 separate sidechain taps from the input signal, which go through independent bandpass filters. And on the interface, we can set the frequency of these sidechain bandpass filters manually, or set it to follow the main frequency control of the band. It is important to note that these sidechain detector modes are not linked, and either band can be set to either mode for maximum flexibility. To finish looking at the signal flow, the sidechain signal then enters the detector, which outputs a logarithmic scale control signal. This signal is inverted and sent to the other band, while the other band's XComp signal is added to the control signal from the detector afterwards. This prevents cross-fed feedback from occurring. This signal then drives the gain for the EQ band or the wideband signal if set to wide. But notice the control signal passes through the gain reduction limiter first. So now we will look at that control. The internal design is clamped at ± 30 dB maximum. But if we engage this GR limit button, we get more control over that behavior. The control on the bottom sets the point at which we would like the gain reduction limit to occur, and it goes from 3 dB to 24 dB. And while the control uses the negative number convention, it is important to note that this limits the maximum increase as well as the decrease. In soft mode, the limit rolls off the control signal at a 2:1 ratio wherever this control is set, and in hard mode, it is a hard clamp to the set level. So now let's take a look at QXComp inside of Plugin Doctor. Immediately we can see the safety limiter does give us a slight volume decrease when it's engaged, which is part of the design to prevent clipping at 0 latency. But again, this feature is designed to be bypassed once you are comfortable with the dynamics behavior. When we look at the face, we see no deviation when oversampling is disabled, and when we turn it on, we see some kind of strange phase response on the upper half of the spectrum. This is because the oversampling employs a polyphase design, not a linear phase design, which creates some phase discontinuity throughout the signal, but had a more defined upper frequency response than the linear phase methods that were looked at for this plugin. Well, at least to my ears. The phase response in Plugin Doctor is also exacerbated by the subsample latency of the polyphase oversampling, which cannot be accounted for by the integer-based sample offsets that plugin hosts use for latency compensation. Really, the phase disturbance and subsample latency will only have a negative impact if we attempt to blend a dry signal in parallel. But since this primarily operates as dynamic EQ bands, parallel operation seems mostly redundant, as we could just lower the gain of the bands for less effect, instead of using a dry signal blend. So this method seems appropriate for this design. Now the harmonics analysis. The safety limiter adds a bit of additional noise floor when engaged, but let's really try to get some visible aliasing here. And we see with the oversampling disabled, we have a pretty good response, but when we turn the oversampling on, we see that we get a much better aliasing response. So now let's look at the response of these EQ curves. The low shelf, and peaking filter, and the high shelf. And we notice that even running at a lower sampling rate with oversampling off, the high band has no cramping in the upper frequencies with either the shelf or peak, all the way up to its maximum 28 kHz setting. So let's take a look at how we might use this to enhance some audio. We have this little groove here. Use the low band frequency control to find the right frequency to target. And then we will start applying some compression. And we'll do the same thing for the high band. Now we will use the gain controls to kind of level the audio spectrum back out. We can see the meters kind of balanced around that 0 dB marker now. Use the sidechain controls to fine-tune the detectors. Now we will feed in some of the XComp and Extreme and back off completely, and now kind of dialed in more tastefully. Now this is with the shelf filters in crossover mode. Let's move to the peak detector and find a good frequency to capture the energy of that band. Now maybe set the low band to the mid channel and the high band to the side channel. And now back in stereo. Now we can exaggerate the filter shape with this Q control and get a more resonant and affected type sound. And we can set the bands to peak filters, and increase the amount of compression and expansion. And now it's pretty intense. But now we can use the gain reduction limit to kind of rein this in better. So we will start on soft and see what that sounds like. And now on the hard setting. And with the plugin bypassed, and back on. So I hope this gives you a thorough understanding of QXComp and how you can use it in your own audio productions. QX Comp is available now for download in the link below.